This video is for section 3-3, the slope of a line. If a hill rises 15 feet for every 100 feet of horizontal distance, the steepness of the hill is the ratio 15/100. Here's a diagram of a hill. Vertically, it rises 15 feet, while horizontally it runs to the right 100 feet. To express how steep that is, we could compare the amount of rise, 15, over the amount of run, 100. In algebra, we call that slope. The slope of a line is its steepness as a ratio of rise divided by run. To describe the slope of a line, such as the graph of 2x minus 3y equals 12, choose 2 points on it. For example, -3, -6 is a solution to that equation, and 9, 2 is a solution to that equation, and compute the quotient. The quotient we're interested in is rise divided by run. To find the rise, we can find the difference of the y-coordinates. The y-coordinate of n is 2. The y-coordinate of m is -6. And for run, we find the difference of the x-coordinates. The x-coordinate of n is 9, and the x-coordinate of m is -3. Now perform these subtractions. 2 minus -6 is 8, and 9 minus -3 is 12. From one point to the other, the line rises 8 units and runs to the right 12 units. This is a reducible fraction to 2/3. The slope of the line is 2/3. Here's a drawing of that situation we were just discussing. You see point M at -3, -6 down here, and point N at +9, +2 up here. We want to know how steep the line is. We need to know how much it rises and how much it runs. So notice it's rising up 8 units and running to the right 12 units. And we get those values by subtracting the coordinates. Here is the slope formula that you learned in Algebra 1 class. Assume there are 2 points on a line. We could call them anything, but here it's called point 1 and point 2. Let's say that the coordinates of point 1 are x sub 1 and y sub 1, and the coordinates of point 2 are x sub 2 and y sub 2. Then we can find the slope, rise over run, by subtracting the y-coordinates and subtracting the x-coordinates. Hopefully that looks familiar to you from Algebra 1 class. The letter m is used to represent slope. And so the formula for slope is m equals y2 minus y1 divided by x2 minus x1. Next, let's work this example problem. Solve 2x minus 3y equals 12 for y in terms of x. First, subtract the 2x term. We get -3y equals -2x and the +12. Then divide by the -3. We get y equals -2x divided by -3 plus the 12 divided by the -3. In turn, this is equal to y equals 2/3 x minus 4. The reason that we did this is to notice a relationship of the coefficients a and b to the slope m. Remember that in this equation, the coefficient of x is a and the coefficient of y is b. The a is 2, the b is -3. When we worked with this equation earlier, we had figured out that the slope was 2/3. Notice how the number 2 is the value of a, and the number 3 is the opposite of the value of b. So there is a relationship between the coefficients of x and y when an equation is in this format and the final slope value. Here's a theorem that shows that. When an equation has the form ax plus by equals c, then its slope is the opposite of a divided by b. Example, what is the slope of this equation? Using the formula m equals negative a divided by b, we can find the slope is negative 5/3, negative 5/3. Now next example, what is the slope of this equation? Notice that this is not in the format ax plus by equals c. Instead, it has the letter y solved in terms of x. This time, it's that number that is the slope. So the slope is negative 2. Whether you have an equation in this form or an equation in this form, it is pretty easy to find the slope. The next skill we're going to review is how to determine other points on a line when you know its slope. Because slope gives the vertical change to the horizontal change between points, you can determine points on a line when you're given a point in the slope. For example, negative 5, 1 is on a line, and that line has a slope 2/3. Then, negative 5 plus 3 and 1 plus 2 would find another point on the line. This turns out to be negative 2, 3. If a line has a dot at negative 5, 1, and you rise 2 units and run 3 units, you can find that next dot. It will be at negative 2, 3. Let's try an example of this. Determine 2 more points on a line if the slope is negative 4 and 0, 3 is on the line. If a slope is negative 4, then written as a ratio, this is negative 4/1. This is the rise, and this is the run. Rise is referring to changes in the y values. Run is referring to changes in the x values. Take the point that you know is on the line and increase its x value by 1 and decrease its y value by 4. This creates the point 1, negative 1. To find another point, take 1, negative 1 and increase its x value by 1 and decrease its y value by 4. That creates the point 2, negative 5. We have found 2 more ordered pairs that are on the line. A line with positive slope rises from left to right. A line with negative slope falls from left to right. A line with 0 slope is horizontal. And a line with no slope, or your Algebra 1 teacher may have called this an undefined slope, is vertical. Let's summarize the lesson. We reviewed the concept of slope, which indicates how steep a line is. There's a math formula to find the slope. It is the difference of the y-coordinates divided by the difference of the x-coordinates. We also discussed how you can use slope and a point to find additional points on a line.